Hi everybody, my name is Greg Anderson and this is the Good Timekeeping Show with Greg Anderson. I've wanted to do this for quite a while. I want to start a little series of episodes about the history of timekeeping. Now, timekeeping is ubiquitous, as they say. It's been around forever. You rarely think about why we keep time the way we do. But sometimes you do think about that, and you might wonder, why do we divide a day into 24 hours? And why do we divide an hour into 60 minutes and a minute into 60 seconds? And who came up with that? Why do we do it? Why don't we have something that seems simpler, like, dividing by 10 or 100, or, what's the deal? All right, so let's get into that. And I want to also, I want to make it clear that timekeeping is always going to be linked with astronomy, okay? We're always going to keep time based on the relative position of what we see in the sky compared to, where we are on the ground. So maybe anciently they thought that the Earth went around the sun, but anyway, it always looks like we're looking up, where is the sun, where are the stars? And we've been keeping time based on those observations for as long as mankind has been around, for all we know. Also, as I get deeper into this, just remember this, we'll come back to it on a future episode. Good timekeeping, precise timekeeping, the best timekeeping possible, is always a very important part of precise navigation. Okay? Knowing where you are, where you want to go, how you're going to get there, how long it's going to take to get there. Precise navigation depends on good timekeeping. All right, just keep that in mind. All right, now what about our 12-hour day and our 12-hour night and our 24-hour rotation of day and night? Who came up with that? Who decided to divide the day into 24 hours? Well, it seems as though this came from the Egyptians. Now, granted, the Egyptians didn't have blogs. They left behind some stone tablets and some hieroglyphics and some clues into what they were doing, but they didn't have blogs and YouTube videos and minutes to the meetings where, the people in charge said, we're going to keep time this way. So archaeologists know a lot, and they've told us a lot, and I understand it pretty well. But I'm going to be filling in some of the gaps with amphibian DNA, if you know what I'm talking about. So as far as we know, it was the Egyptians who decided to divide the day into 10 hours, including the first hour of morning light, that's an additional hour, and the last hour of twilight at dusk, okay? So then that became 12 hours, and the Egyptians seem to be the people who started that up. They're keeping track of 12 hours. Well, their hours weren't necessarily of equal length, but they were close enough that they could, they could keep time and they could do something with their 12-hour timekeeping method. Most of their timekeeping was done with what we would call sundials, okay? So watching the shadows of objects and how they hit the ground at certain times of the day, and watching how those patterns repeated day after day. That's pretty much how the Egyptians decided to keep track of their 12 hours in their day. Now, someone also figured out that nighttime was about the same length as the daytime, maybe some variations throughout the year, but eventually it evens out. So that's where we came up with 12 hours of daylight, 12 hours of nighttime, and a 24-hour day. Now, why did we divide the hours into 60 minutes and the minutes into 60 seconds? This appears to have started with the Babylonians, the ancient Babylonians. We're talking, over 2,000 years before Christ. And in fact, they got a lot of their basic math from the Sumerians, which were, 500, 1,000 years before that even. So the ancient Sumerians, they really liked what we would call base 12 and base 60 number systems. Now, you might have to go back and refresh some of the math that you learned in junior high to know what I'm talking about. Of course, most of us know that binary is a number system of ones and zeros, and most of our computer technology, uses this binary language. For the codes that are working deep inside your computer and that you never have to think about. So a whole bunch of ones and zeros, which can somehow translate into the things that we see on the computer and the things that we put into the computer. So that's base 2, binary. Base 10 is what most of us are used to, of course. We count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we start a new set with 1, 0, so 10, and then we add 1, so it's 11, 12, 13, 14, 15, and that's how we do it, and we've been doing it forever, so we don't think twice about that. A lot of people think, oh, base 10, we like to use it because we have 10 fingers, and it makes it easy to do math. However, that's not necessarily true. Now, probably you have a pretty good grasp of math, I would say. You know, we're all pretty good at addition and subtraction and multiplying. But what about division? That's probably where we can't quite do it in our head quite as rapidly when we have to divide numbers, especially in base 10. Because what if you want to divide the number 10 by 4? Well, you get 2.5. Well, okay, now you're dealing with decimal places and fractions, and so then most of us use our phones. You know, we've got a calculator in our pocket, and that's how we deal with decimal places and fractions and all that. We don't have to worry about it because we just do the math on the phone. But what if you didn't have a phone? Like the ancient Sumerians, apparently their phones were terrible. Oh no, actually they didn't have phones. So they had to do all the math in their head. Okay, so what happens when they want to divide, say they're selling 10 eggs and they want to divide that by 4. Okay, so I'm going to give you 2.5 eggs. Now, wait a minute. How are you going to sell half an egg? Okay, I challenge you, even with our current modern technology, to somehow find a way to give somebody half an egg, half a raw egg, okay? Not one you've already scrambled up and cooked. Okay, it's really hard. Well, okay, so what if you take the 10 eggs and divide it 3 ways? Now it's 3 1/3 eggs. Again, how are you going to get 1/3 of an egg? Well, so the ancient Sumerians, you're a merchant in an ancient Sumerian market, and instead of selling your eggs in groups of 10, you're selling them in groups of 12. And now if someone wants to divide that by 4, well, now it's 3 eggs. Or what if they want to divide it by 3? Now it's 4 eggs. Easy, right? You can make those calculations in your head, and you don't have to worry about how to sell half an egg, right? So now let's just look at the number system, and why is it so much easier to divide numbers when you're in base 12? Well, think of it. When you're in base 10, you have you're able to divide certain numbers without ending up with fractions, but you're limited there. You can divide by 1. I don't really count that. 10 divided by 1 is 10. Come on, divide by 1 doesn't count. Divide by 2, okay, then you get 5. Then you could divide by 5 and get groups of 2, or you could divide, by 10. So again, I don't want to really count dividing by 1 or dividing by the number itself, dividing by 10, but they're in base 10, your first 10 numbers. You can only divide by 2 and 5. Everything else is going to give you fractions or decimal places. But what if your number system was based on 12? Now you can divide by 1, 2, 3, 4, 6, and 12. So right there, you've got a much more versatile number system when you need to do division in your head. Okay, now let's take it one step further. Since our base 10 is not very good for doing division, okay, let's just multiply that by 5, and let's just say we're going to go by base 50. Okay, you haven't added a lot of versatility if that's what you've done, because now you have 1, 2, 5, 10, 25, and 50. Okay, yeah, you haven't added much to that, but if you had your base 12 and you multiply that by 5, and now you're going with a base 60, now you can divide by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. Now that's a pretty versatile number system you've got there going there. So that's why the ancients seem to be really excited about base 12 and base 60 and not so much base 10. And you might be wondering, well then how do you count on your fingers if you want to count to 12? You only have 10 fingers. Well, here's a neat little trick that they did. See, you've got sections of your finger. You can count to 12 on one hand because each finger has 3 sections. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, see, and then you've counted on one hand. So you can imagine, rather than a pocket calculator or a calculator on your phone, these ancient Babylonians were probably doing a lot of this on their hands in the market while they were trying to figure out, how to do commerce. So really, these guys were pretty sophisticated, even though we think of them as being, ancient, and what did they know? It turns out the Babylonians knew trigonometry. Yeah, we found some ancient stones that show that they knew trigonometry, and they were doing it in their base 12 number system. In fact, they knew the Pythagorean theorem 1,500 years before Pythagoras was born. They called it the plagiaristic theorem. Not really. That's some of that amphibian DNA I was talking about. All right. Oh, and incidentally, you remember the Pythagorean theorem, right? It's the a squared plus b squared equals c squared, with a right triangle, and you remember that, right? Well, what about an equilateral triangle like this one, where this is not a right triangle, see, because all the sides are the same length, and so each angle here, each of these angles is 60 degrees. You remember this from junior high math, right? So this is an equilateral triangle. Now, what if you took this with 60 degrees for each point, and what if you assembled 6 of these in kind of a circular orientation? All right, I happen to have one right here, so here's kind of a circular thing you've done, and you got right here in the middle, 60 degrees off each of these triangles. And so, 6 times 60, that's 360 degrees. And that's something we still use today when we talk about measuring angles, on a circle, or you've got bearings on a compass. We're still talking about 360 degrees for a circle. And, that all comes from ancient mathematics that they figured out a long time ago. So you might think, it's kind of confusing that we're all based in base 10, and, why does a circle have 360 degrees? This is why. And ultimately, this does make the math easier. Because, again, when you want to divide your circle, and now you've got 360 degrees to divide up, you can divide by a lot of numbers there without having to deal with fractions and decimal places. Also, the ancients knew that a year was about 360 days. I suppose maybe they added some leap days every year or something to make it right. The ancients were pretty good at astronomy, but it kind of makes sense that they were into, sixes and 12s and 60s and 360s, and they knew that, 360 days in a year, almost. And how about 12 months in a year? You see, there's a lot of stuff that we still carry over from when the ancient people were doing this base 12 and base 60 stuff that you don't even think about anymore, but it's ubiquitous in your life. It's everywhere. And even though when I talk about base 10 versus base 12 or base 60, you probably think, oh, it's very confusing. I can't deal with anything. I'm used to base 10. Just leave me alone. But actually, you're much better at base 12 and base 60 than you think because of these things that are carried over. For example, think of this. How many inches in a foot? 12. Yes, that's right. How many eggs in a dozen? Ah, yes, and we still sell eggs by the dozen. How many donuts in a dozen? Okay, 12. Why do we sell donuts by the dozen? Well, because of the ability to divide. Because when you buy donuts, you have to, divide them up among your coworkers, right? That's only fair, right? So, if you only bought 10 donuts and you had to divide that, 6 ways, oh, that's just trouble. And no one wants to have the donut that's partially cut. If you leave that in the box, no one's going to touch that, right? But if you can divide it up with, whole donuts without fractions, so that's why we have to still sell donuts by the dozen, right? So again, it's inches, eggs, donuts, months of the year. We're still using 12s for all of this. And how about this one that everyone forgets about? How about music, okay? We know our scale, do, re, mi, fa, sol, la, ti, do, right? Okay, that's 8 notes. 8 notes in an octave. Oh, but wait a minute. Let's think this through. What about the sharps and flats? Okay, think of that. All right, so if we add the entire chromatic scale, then it's 13 notes. Well, that's not 12. Oh, but wait a minute. That first note and that last note are in different octaves. So the one octave only includes 12 notes. And that 13th note is part of a new octave, see? So we're even doing music that you listen to all the time, and you're better at it than you think you are. It's a base 12 musical number system. Wow. And just one more proof that you're better at base 12 and base 60 than you think you are. I'm going to show you something that a lot of us have, something like this that we wear on our wrist. It's the stopwatch function on my G-Shock Casio watch. And look at this, right here on this one screen, you've got base 12 because it's counting the number of hours, okay? And then you've got base 60 because it's got minutes and it's got seconds, and those are counted in units of 60. And then, look at that. When modern man decided that they needed to divide the second into something smaller, they didn't use base 60 anymore, they used base 10. So there on your stopwatch, you've got tenths and hundredths of a second on display right there on your stopwatch. So all of that mixed together right there on your watch. Base 12, base 60, base 10, it's all there, and you know it better than you think you do. All right, so that's how we got to where we are with the way we keep time as far as how we count it. But in a future episode, how about the way we keep time as far as how we measure the passage of time? Oh, there's a lot of great ways we do that. And I'll get into those in future episodes of this time history lesson on the Good Timekeeping Show.